Today we're going to be seeing how two strands of DNA that differ in one nucleotide can produce completely different proteins. And so we start here with our DNA sequence. Five sets here, codons. And in order to make a protein in the end, we need to go from DNA to mRNA. That process is called transcription. So when the DNA goes to mRNA, the new base pairs, which when you're doing DNA are A and T and G and C, those now change to A and U, and G and C will remain the same. The thymine here is no longer when you're doing RNA, and the U, uracil, is going to replace that, essentially. So now we start at a spot that is kind of dictated by what is called a promoter. And so the promoter tells the RNA polymerase where it's going to start adding base pairs. So if your promoter prompts it to start right there, that is where it'll start. This is your promoter. And so from there, the RNA polymerase does what is called transcription, where it'll take all of these base pairs and bring it down to this bottom side in the mRNA format. So here we have AUG, AUC, CGC, GUA, and UCG. So now that this mRNA has matched up with it, the process of transcription is good to go. And so now it starts the process of translation, where this is sent over to the ribosome, where it is able to actually make the protein. So all of these are codons, and when matched up with the correct anticodon, will produce an amino acid that, when linked together with a lot of things, will eventually shape our protein. So next, we'll get to the process of finding your amino acids that you need. Once the mRNA strand has gone through the transcription process and the post-transcription process, it is sent over to the ribosome, where each one of these sets of 3 nucleotides called codons is going to be matched up with an anticodon, which is like a strand of transfer RNA that comes 3 at a time and matches our set of mRNA. So we're going to get a UAC. And so now that these are matched up, a slow process happens where they process the amino acid, the mRNA, and one at a time, the amino acid will connect to the next strand and then the next strand. So then we have 1 here, now we're gonna have 2, now we're gonna have 3, now we're gonna have 4, and then we're gonna have 5. And this process will continue over and over and over again until eventually so many compile and it eventually stops, where it is ready to fold into a shape that dictates what the protein will be. This is the process of translation. Now that we've done that process with 1 strand already, we can see how it differs if only 1 nucleotide is different. And so as you can see here, we have the original base pairs on the top, and this time we've just skipped this letter A and added it all the way back here at the end. So everything will move down 1. And so as you can see, other than this very first one, we get a different base pair each time. And so that will result in a completely different protein. And so the exact same process of transcription happens. The mRNA comes in where the promoter prompts it to, and then the RNA polymerase adds in the base pairs to match. And we're going to get those amino acids that'll go over to the ribosome for the process of translation, where they're matched up, these codons with anticodons, and those produce a chain of amino acids. So we're going to look at the amino acids produced with the first DNA sequence and the amino acids produced in the second DNA sequence, and look at how drastically the differences are. So now that we've done the process of transcription and translation with each of the DNA strands, we can see the original strand and the new strand produce a completely different list of amino acids that when these get chained together will produce very different proteins. So in our original, all DNA or all strands start with methionine. Then in our original we have isoleucine, arginine, valine, and serine. And then in our new strand, the methionine remains the same, but now we have threonine, alanine, tyrosine, and arginine. So the only one that is the same is this arginine, but now it's in a completely different spot. So this will ultimately create a completely different protein. Even though we only changed one letter, the patterns here and these strands are completely different. We did not get any of the same amino acids chaining together. And it's just such a big chain reaction that one little thing can cause such a big drastic change.